Hey y'all, Miss Kennedy here from Algebra Student. Let's look at graphing a quadratic that's in standard form. So the key here is that we see it's in standard form because we know standard form is just ax squared plus bx plus c. So that's what we have here. We have our a term in front of the x squared. We have our b term in front of the x, and then we have our c term. Okay, and so the thing that we have to remember with standard form and graphing is that we've got to use this formula negative b over 2a. That's going to be the key to figuring out kind of where we're heading here. So I know that a is negative 1/2 and b is 4 and c is negative 6. So I'm going to plug into that formula negative b over 2a. And so I've got negative something over 2 times something. And that is my template I use every time. It just helps me to make sure that I'm remembering to negate the b value and to double the a. All right, so negative b. B was 4. So I put a 4 there. 2 times a, that's negative 1/2. And so that's what negative 4 over half of 2 is 1, and that's a negative. Okay, so I get 4. So I've got the first part of my vertex. And the vertex is what I need first in order to go over here to the graph, whichever direction it points on your screen, so that I can graph it, so that I can get the parabola onto the graph itself. So what I have to do is I have to plug in that 4. I need the function of 4 in this function. Okay, so I'm going to say, I'm going to copy this down exactly like it is. Negative 1/2 times x squared plus 4x minus 6. So I copied it exactly, except where x is, I substituted a parentheses. But everything else is the same. And then I'm going to plug in what x equals. X is 4, because that's what we found it to be right here. All right, so 16, half of that's 8, negative 8, plus 16 minus 6. Okay, 16 minus 8 is 8, 8 minus 6 is 2. So my vertex is 4, 2. So that's going to be very useful to me as I'm working through this problem. And that's just how you plug that in. If you've got that handy dandy calculator, it really is handy dandy because, you know, it'll plug this in really quickly. Negative 1/2 parentheses, plug in that 4 squared. What was it? Plus 4 x, and x was 4. And then minus 6. So that tells us that it's 2. We can go to the table, which is kind of cool. We can type in negative 1/2 x squared plus 4x minus 6. And we type it in exactly the way it was printed on the paper or the screen, however you received it, and hit enter. And I'm going to start at 4, since that's my vertex. And I see that that's 2. And if I move up, notice the symmetry that I have around that 3 and 5, the numbers above and below that vertex have the same y values. That's showing symmetry. And we know that a parabola has the symmetry of either, it's either opening upward or downward, but it's symmetric. And, your drawings are much better than mine, I'm sure. All right. So that leads us to our next question that we have to think about. For most classes, you're going to have to name the axis of symmetry. So AOS, axis of symmetry. And that's an X value because it's always going to have that axis, that symmetric line running vertically. So it's going to be at X. So it's just whatever your X value was from your vertex. I'm pointing over here. Doesn't look like it. And then we need to know how it opens. The way that we know how it opens is we look at the A value. And so A was negative 1/2. We have that written here as well. So if we know that it's a negative, then we know this opens down. Okay, so that opens up a lot of information for us. So I'm going to come over here and we're going to graph it at 4, 2. So I've got my little coordinate plane, not so little actually. And I'm going to go right 1, 2, 3, 4, up 2. There is my vertex. And I know I need an axis of symmetry at x equals 4. So I'm going to draw that. We're going to pretend that it runs right on the line. And you always want to make that a dashed line. So we've got our axis of symmetry. We know that it opens down. So for some of you, it's going to be enough to just do this and your teacher's good with a sketch and you're done. But for most students, I would think your teacher's going to want you to get a couple of more points because this has a vertical shrink in it. So it's shrinking down. That means it's going to be a wider parabola than just a normal U shape. So the way that we would do that is one of the ways is we can just find a couple of points. Like we know 4, 2 is a point, on this graph. We need a point on the left and a point on the right. So if I'm looking at the graph at 4, then a point to the left of that would just be at 3, and a point to the right of that would be at 5. So let me take those off. I just wanted you to kind of visualize where I'm getting this from. And so then you would go back and you would plug in to the original equation here, a 3, see what you get, and a 5, and see what you get. However, if you're using this, if you're using a multi-view calculator with a table function, you can probably look at that and just kind of see. All right, so I see that it's 3/2. I don't know where 3/2 is on my graph, right? That's confusing to most of us because fractions, bleh. So one of the super things is I can hit this toggle button and it will just automatically change it and show me that that is actually 1.5. So at 3, it's up 1.5, and at 5, it's up 1.5. So I can graph those 2 points. So write 3 and up 1.5 will approximate, and write 5 and up 1.5. And then that gives us a general direction and general outline for our parabola. Not beautiful. Yours is better than mine. I am sure of it. No doubt in my brain about that. Your teacher may require 2 points on either side to get a better sense of the parabola. But one thing we can always do is just double check. Does this open down? Yes, it opens down. And it's, you can tell a little bit that there's a width there that wouldn't necessarily normally be in a general parabola. Maybe it's a little bit, wider out than normal. So you may be required to state domain and range and other things like that. And that's good and important, certainly as you move forward with Algebra 2 coming up, if you're in Algebra 1 right now. But this should get you started. Thanks. Bye.